Welcome to the Curious Head channel. Here you will find a variety of interesting facts and amazing stories on a variety of topics. Subscribe now so you don't miss any updates. According to scientific research, this strategy may enable warm water marine creatures to regulate their body temperature while hunting. The findings have surprised experts, including Mark Royer, a shark biologist at the University of Hawaii who led the study. He states that this behavior has never been observed in deep-diving fish before, raising questions about the prevalence of breath-holding among other species. Scalloped hammerhead sharks, which are critically endangered, usually rely on forward movement to circulate water over their gills and extract oxygen. However, when they swim down to great depths of half a mile to catch prey, the colder water could adversely affect their metabolism, cardiac function, and eyesight, compromising their hunting ability. To mitigate exposure to cold water, these sharks have been observed closing their gills and mouths, effectively holding their breath. Unlike other species like bluefin tuna and mako sharks that possess specialized adaptations to conserve body heat in cold waters, scalloped hammerheads lack this advantage. Scientists previously theorized that these sharks rely on thermal inertia, using their large body size to maintain their temperature and carry heat as they dive into cold depths. An analogy drawn by Marianne Porter, a biologist studying shark movement at Florida Atlantic University, compares it to thawing a frozen turkey, where thermal inertia would account for the slow thawing process. However, the researchers' use of small sensors placed on adult scalloped hammerhead sharks, acting as a Fitbit for sharks, suggests that thermal inertia alone does not explain how these sharks remain warm during their deep-sea hunting expeditions. The study involved analyzing detailed information on swimming behavior, depth, and location from a small group of 6 male sharks that completed over 100 dives in Hawaiian waters. The sharks' muscle temperatures were recorded using tiny probes during nighttime dives. This data, combined with further modeling, indicated that the sharks managed to maintain their body temperatures even at depths of more than 2,500 feet, where temperatures dropped significantly. Interestingly, the animals' body temperatures did decrease slightly when they ascended and reached slightly warmer waters on their way back to the surface. This suggests that the sharks open their gills to obtain oxygen, contrary to what would be expected if thermal inertia were the primary mechanism at play. Although the researchers did not directly observe the sharks closing their gills, they suspect that this behavior occurs. To confirm their hypothesis, the team plans to attach cameras to the pectoral fins of these hammerhead sharks to observe the opening and closing of the gills during dives. The origins of this breath-holding ability in the 12-foot-long species remain unclear. Royer suggests that the sharks may learn it through social interactions with other diving hammerheads or by following the example of other animals that hunt at similar depths. Compelling evidence supporting the breath-holding conclusion includes prior footage of an adult scalloped hammerhead swimming with closed gills at over 3,000 feet below the surface, as well as footage showing the species with open gill slits in surface waters. Additional experiments conducted by Royer's team using deceased hammerheads in warm and cold water baths further support these findings. Marianne Porter, who was not involved in the study, finds the evidence presented in the research to be convincing. She believes that female scalloped hammerhead sharks, which also undertake deep dives, likely exhibit the same breath-holding behavior as non-pregnant females were not included in this study. According to a scientific commentary published in Science by Mark Meakin from the University of Western Australia and Adrian Gleiss from Murdoch University, the implications of this breath-holding ability are remarkable. If these rapidly declining species can hold their breath while foraging at depth, they may adapt better to the low-oxygen environments that are becoming increasingly common in our changing world. The authors note that scalloped hammerheads already inhabit low-oxygen waters in the Gulf of California, and the newly discovered breath-holding skill may explain their presence there. While these animals may survive in low-oxygen areas for short periods, sustained exposure to such conditions may not be viable in the long term, raising concerns about the species' future adaptation and survival. Thanks for watching, a big hug, until next time.